Hi everybody, my name is Max Maker and this week I'm building a vibratory tumbler. You might have seen my previous video where I built a rotary tumbler, but it works well, it's just a little bit too small for my parts. As some of you might know, I'm building these drawer slides for RVs and they are quite large, and some of the parts arrive in a very nice condition, like these ones over here, so they're about 1.20 m long. But some of the parts, they have fingerprints on them, and with the fingerprints they really etch into the aluminium and you cannot just clean them off, they're etched in. And some parts of course have these sharp edges like these little snaps, so I want to build a vibratory tumbler out of these scraps that I had lying around anyway. So I set up this little frame and I used a combination of joining methods here. On top I've got some screws that go into the core of the profile. Then here I've got some of these connectors which are super fiddly. They take a ton of time to assemble. It's like a little cylinder that you put into this thing, and then a screw goes in from this side into one of these little nuts. And to get the diagonals in, I clamp them in and then I scribe a little line and I cut along that line and then I can put it in. And the goal is, since I just bought a welder, that hopefully I'll be able to weld all these joints, so if the screws fall out eventually, it doesn't matter. So let's weld this up. We are here in the exit of my underground workshop. This is like a car lift, so I don't have to worry about the ventilation. And I just played around with the settings. This is the first time I'm actually welding on my own. I only welded maybe 5 minutes at university. So yeah, I was keen to learn this and I thought I might as well try on these parts since I didn't have anything else to work with. And I'm quite lucky with how they turn out. It's tricky to weld this stuff because the seams are always so very short, just like 5 or maybe 10 millimeters long. But it worked out okay. I think they're joined, they're not pretty, but I got a lot better since then. And just when I was done, the tub arrived. I had this made by my sheet metal manufacturer since they're really good at this stuff and they can weld these big parts. I wasn't so confident to make this myself. I added some wheels underneath the frame and now I'm coming in with my manual forklift, and this is just a test fit to see how this tub will fit in there. I designed the tub just a little bit bigger than the biggest parts that I need to tumble, and I'm drilling some holes in the top here to mount these springs. These are actually springs from trampolines because I can get them really cheap and I know about roughly how much force they can exert basically. At this moment I was worried that they could backfire, so I was wearing a face shield. Yes! That was a bit frightening, and it still is, but it's on now. I made up the design as I went along the build, and just suspending the tub once gave me a whole lot of more ideas on how to stiffen up this frame. So first of all I suspended everything with the forklift to make putting it in and out of there easier, and then I used this 8mm plate to get a dedicated place to hook on those springs. And welding this fixed stuff is really easy. Yeah, now they just hook on like this. I also put this diagonal in so this corner doesn't move that way anymore when the thing is swinging. And that's the basic frame done. This took me like 1 day to make, so it's quite easy to do actually. There isn't a whole lot of information on the internet on how to build something like this, so it was a lot of trial and error. But I'm lucky with this as it's working right now, and now we can focus on the motor assembly because this needs a lot of power. This is the VFD and this is the cable for the motor, and this is shielded. Apparently you need that if you want to drive a VFD. And here's the huge motor. These are the specs if you're interested. Yeah, extension cords are cheaper than actual cables for machines. And this is rated for all of this, so it's all good I would say. And this motor had to be wired like this, and this is Delta apparently. I don't know about this stuff, I just followed the instructions that were written inside of the lid and made sure everything is reasonably waterproof and of course vibrations proof. So that's why I used some lock nuts, I used some Loctite and some zip ties to hold everything down in case something gets loose with the vibrations. Because at this point I was hoping that I would let the motor vibrate together with the tub. There are like 2 ways to build a vibratory tumbler like this, and one is to mount the motor directly to the tub. That's what I planned initially. Then you have a counterbalanced weight, and as that moves up and down it shakes the whole tub. But of course the motor is also vibrating, which I didn't want, so I put the motor next to the tub and then it's going to be connected to the unbalanced weight with these universal U-joints, so it's independent. And to mount the motor, I used this 4mm piece of really bad aluminium. This is so soft I can bend it with my hands. I'm happy this is out of the way and out of my workshop now, and it serves a purpose. And I had to mount this really low down so I had enough space for the top. So this is a universal joint that I bought on eBay. It's 40 years old at least. It's made in former east of Germany and it's really good quality. Something like that would probably cost €1,000 nowadays. And to put grease in there's a little hole and you can just use a syringe and pump out the old grease and get some fresh in there. It's a little bit rusty and I found the original documentation from 1984. So this shows you everything that you can do with these kind of couplings and also the dimensions and the right and the wrong way of assembling these. And Reddit actually helped me with finding out how to get the grease into these because you cannot take these apart. Anyway, I had to make some adapters on the lathe to couple everything to the shafts and to the weights. And to get the shaft on there, I used Loctite and then one securing screw in case this Loctite fails, then the screw will keep it together, and I guess I'll hear if it starts to shake around. Some of these had tapered pins and these are very nice, but I didn't have a way to machine them. So this is the transmission shaft. This will be coupled to the motor. This thing can slide in and out to compensate any of the vibrations, and along this shaft right here that will be welded with these two tabs to the top, the vibrations will happen. So we have a counterweight on here. At the beginning I will try to use these two holes to attach just a weight to them, and I don't think that's enough, but I'll try with something small first and then I go with something bigger that clamps to this. One side of the shaft had this spline that I couldn't machine at all, so I just 3D printed a coupler and that fit the motor and also the shaft. As I said, this was a lot of trial and error. And it was time again to move stuff around. And that test fit looks very promising. The tub can move completely independently from the rest of the frame. So it's time to weld on these bearings permanently. I'm using these scrap pieces that I had bent once for a product that I'm not selling anymore. And you know, I'm not a welder. I just looked up some welding videos on YouTube. This looks like crap, of course, but you know, it works. It's functional. It's holding up fine. So don't be discouraged from starting a welding project just because you can't weld. You can learn anything. That's what I said on this channel. Quite a lot, I think. And this works. So the counterweight goes on the shaft that's spinning on the left, and the shaft on the right will be connected to the motor. So now I welded this whole package onto the tub itself, and here you can see that the weld probably penetrated a little bit too far. I guess that's a good thing, so back down into the workshop and let's give this a try, test if the motor can actually vibrate the tub. I have no idea at this point what's going to happen, so let's hope for good vibrations. There are vibrations, you can see them, but they're on the wrong side. They're at the motor side. If you look at the coupling, that's where the vibrations are happening, because there must be some kind of unbalance there. So the problem was that this big and heavy shaft was coupled to this one with a 3D printed connector, because I can't really machine any slot for this, and I cannot machine this because this is attached to this permanently via a push fit. This assembly here on the inside is push fitted into here, and you can't push it out from this side because it's not a through hole. So this is in there permanently. There's no way to get it out. So what I thought now was I can put a shaft in here, and instead of connecting this shaft directly to this piece, this shaft will be a little bit longer until here maybe, and then I have a bearing block here, one here. So this thing is then fixed between those bearing blocks, so it cannot wobble anymore. I let the 3D printer print a bracket for the bearing, so that gave me some time to add some more braces to the frame. So I was down in the workshop while the 3D printer was doing this part. And it came out quite nicely. And I ended up with this monstrosity. I mentioned this is a prototype, right? I don't care how it looks like, I'm totally happy with this. I'm learning welding, I'm using up scraps, so that's all good. And I know a machine like this would cost a lot of money if I bought it, so I'm happy. But let me know in the comments what you think about it anyway. I still needed some kind of coupling to connect the motor to the first spinning shaft, and it's a prototype, so I don't know if these gears are going to work out or not, so I just 3D printed them. It's much cheaper, much faster than waiting for parts. It was a bit difficult to get them on, but overall they worked surprisingly well. I couldn't see any wear even after 1 hour of operation, and they didn't heat up. So I'm quite pleased with that. Oh, and I'm adding this tape so the pins cannot fly out. Very nice. No vibrations on the motor at all. The coupling is totally fine. And I don't have a counterweight on there yet, so we don't have vibrations. But that's going to change in a minute. Yes, it's vibrating. Perfect. That's such a simple concept, isn't it? And it's a very simple machine as well. It's just getting the right dimensions and the right parts together. So let's add some finishing touches before we put the media in there. And this is a through-hole connector for rain barrels, and that will allow me to drain some water if I ever add some processed water to this to get rid of the dust that will eventually be created by the vibrations. So that went in there very easily, and of course I need some kind of filter so the media itself doesn't flow out. And I use this brass piece with a end cap at the top. And I just use brass so it's easy to drill. That's the only reason, because drilling steel is not as fun as drilling brass. And this was the most expensive part of the whole build. So this test was not great. The vibrations are only in one corner, and that makes sense because the counterweight was in that corner. I probably should move that counterweight into the middle of the drum and then connect it with another shaft and another pulley and maybe a V-belt. So now the vibrations are happening in the middle of the tub, and the tub is going to shake uniformly up and down and not just one corner. So add some more bearings, like this one right here. If you enjoyed this video so far, please subscribe to the channel, that really helps out. There we go, and the pulleys arrived as well. Of course I ordered the wrong size, so I had to machine them a little bit, but that's okay. This was the first wave, second weight, third weight, fourth wave, weight fifth, and sixth, and that still wasn't enough. So now I've got this one here, beautifully welded on by myself. And I will try out this. Now we're cooking. It turned out we only needed a little bit more weight, so 1.5 kilograms is the counterweight at the moment, and it's spinning at 60 Hertz. And after this was running for a few minutes, I looked at the slow-mo footage and I saw that one of the welds had cracked. So I welded on some supports and made this into more of a box section, like a geometric shape instead of just a single sheet of sheet metal. And it looks very bad now, but now everything is spinning uniformly. So the whole tub is vibrating and not just the mounts for the bearings. I know it looks very messy, but we've got the motor. The motor transfers the power to this pulley, to this shaft. This shaft can then isolate the tub from all of the frame, and then this shaft is coupled with this pulley, with this shaft, and now we've got the mass in the center of the barrel, because apparently that's important, otherwise only the left side shakes when I had the weight down here. So now it's much better. This is the weight, it's just on there temporarily, but it holds up well so far. I want to make it a bit more secure, of course, and there will be some kind of cover in case this flies off. So this is a temporary sheet metal cover in case something comes flying off. Ultimately, the counterbalance will be completely encased with a 4mm thick welded steel bracket. But for that, I just want to be sure that I'm going to keep this current configuration. And now I'm spinning some parts basically. Well, I call it spinning or tumbling. Vibrating. It draws 4 amps, so the motor is well under control. It can go all the way to 8 amps, I think. And it's going in a nice motion like this. And after about one rotation, the parts look like this, so just a few scratches. And if you leave them in for about half an hour, I leave them in, they come out like this. Perfectly smooth, with a nice matte texture, and you cannot see any scratches anymore. Here you also see the rounded over edges, just like I wanted. And you cannot see the scratches. On the right it's the same material, but on there any scratch is visible straight away, but on the left it isn't. Cost-wise, I spent about 2 grand on this, so I think it's well worth it. Since something like this I would have spent 10 or 12 grand probably. And this corner is its final home, at least for now. Next up, I need to paint this obviously to get rid of the rust, maybe coat the inside with something, not sure about that yet. And I will build a proper steel enclosure around the counterweight. but I waited for that until I knew this is running, and I'm not going to change it anymore because the housing will be quite elaborate, I think, so I want to make sure I don't have to change it down the road. So in conclusion, if you need a tumbler, just build it. It's not difficult. All you need is a heavy weight that spins around the shaft really fast. And I learned a lot in this build, especially that this right here, this border around a tub like this is really important to stiffen it up. Working with these VFDs is really, really easy. You just need to hook it up, set some really basic parameters like the maximum current, and that's it. I thought that would be super complicated. Yeah, apart from that, and you can learn how to weld really easily. All you need is to practice a little bit. But you certainly don't need some kind of formal education to just weld something at home. I mean, this is holding up. It's not looking pretty, and I'm sure there are many people out there that will tell me this is not going to hold up, but it's been running for 8 hours a day for the past 5 days straight. It's tumbled all my parts now, so it's pretty much done for the year. And for the costs that I paid for it and the 2 weeks of time, I don't think I could have had all of this stuff tumble vibrated at a company that does that for a living. So yeah, thanks for watching, guys. My name is Max Maker, and I hope I inspired you to tackle a project that you aren't sure about if you could do it or not. Thanks for watching, guys. See you next time. Oh, and please like, subscribe and comment, of course. These subscriptions, they really help out.